A new wave is beginning in the EV industry. From the outside, everything looks normal, but behind the scenes, something significant is changing. Recently, Elon Musk spoke about a motor that doesn't rely on rare earth materials. At first, it sounded like just another technological upgrade. But the real question isn't simply whether a motor can be built without rare earth metals. The bigger question is what kind of hidden technology might be inside it. Technology that could potentially shake the entire electric vehicle market. The truth is that today's EV industry heavily depends on certain metals. If a company finds a way to break that dependency, the competition will no longer be just about price. It will become about control. Who can build the technology, how quickly it can be produced, and which companies will fall behind. Within the industry, people have already started whispering about this possibility. Is this just another motor design, or could it represent one of the biggest technological shifts in the future of electric vehicles? So how is Tesla's move pushing Toyota to rethink its strategy? And why could this development disrupt the electric vehicle market in the coming years? What you'll discover in this video might change the way you see the future of EVs. Before we dive deeper, make sure to subscribe to the channel so you don't miss more videos like this. To understand Tesla's new motor, we first need to understand Tesla itself. Today, when people hear the name Tesla, they think of futuristic cars, automation, and cutting-edge technology. But there was a time when the name Tesla made people smile in disbelief. Many believed it was impossible to change the world with electric cars. Even Elon Musk was often seen as a wealthy dreamer spending his money on unrealistic ideas like rockets and electric vehicles. Tesla was actually founded in 2003 by Martin Eberhard and Mark Tarpenning. Their vision was simple but ambitious. Create a car that didn't use gasoline yet could still be fast, stylish, and exciting to drive. Elon Musk wasn't a founder, but in 2004 he invested in the company and gradually became its most recognizable figure. At that time, electric vehicles had a terrible reputation. Most people believed EVs were slow, unattractive, and impractical. Tesla challenged that perception in 2008 with the launch of the Roadster. The Roadster was the first electric sports car capable of accelerating from 0 to 100 kilometers per hour in about 4 seconds. It proved that electric cars could be exciting. However, success didn't come easily. In fact, 2008 was almost the end for Tesla. The company was running out of money, facing major production challenges, and investors were losing confidence. During that difficult period, Elon Musk invested a large portion of his own personal fortune into the company. Many people thought he was taking a huge risk, but Musk didn't give up. Then in 2012, Tesla launched the Model S, and that's when the world really started paying attention. It wasn't just another electric car. It was a luxury vehicle with impressive range and powerful performance. For the first time, people began to realize that electric vehicles might truly represent the future of transportation. After that, Tesla's momentum kept growing. In 2015, the company introduced the Model X. 2 years later, the Model 3 arrived and brought Tesla into the mass market for the first time. The Model 3 made electric cars accessible to a much larger audience. Later, the Model Y strengthened Tesla's presence in the fast-growing SUV segment. Today, Tesla is no longer viewed as just a car manufacturer. It's widely seen as a technology company. Looking at Tesla's sales numbers tells the story clearly. In 2015, the company sold around 50,000 vehicles worldwide. By 2020, that number had grown to roughly 500,000 vehicles, and the growth only accelerated from there. In 2021, Tesla delivered about 936,000 vehicles. In 2022, sales rose to approximately 1.31 million cars. By 2023, Tesla was selling around 1.8 million vehicles annually. This means that the same company people once laughed at is now delivering millions of vehicles around the world every year. Tesla didn't just sell cars, it made electric vehicles exciting and desirable. It proved that EVs don't have to be slow or boring. Innovations like the supercharger network, over-the-air software updates, and autopilot technology helped Tesla stand apart from traditional automakers. Today, Tesla operates in major markets across the globe, including the United States, Europe, and China. With its gigafactories rapidly increasing production capacity, the company continues to expand at an impressive pace. That's why when Elon Musk talks about building a motor without rare earth materials, the industry pays close attention. Because despite its futuristic image, the EV industry still has a major weakness. And that weakness could shape the future of electric vehicles. Electric cars promise a quiet and fuel-free future. They glide down the road almost silently, powered by advanced technology and controlled by sleek digital screens. On the surface, it feels as if the future has already arrived. But behind this shiny image lies a reality that is rarely discussed. The EV industry depends heavily on rare earth metals. Most electric vehicles today use motors that contain permanent magnets made from rare earth elements such as neodymium and dysprosium. These magnets play a crucial role in the motor's performance. They allow the motor to deliver smooth torque, high efficiency, and a compact design. Much of an EV's speed and performance comes from these components. However, unlike common materials, such as iron or copper, rare earth metals are not widely available. Their supply is limited, and extracting them is complicated and expensive. This is where a major weakness in the EV industry begins to appear. Whenever an industry depends on a limited resource, stability becomes a challenge. Prices can suddenly rise, supply can be interrupted, and manufacturers have little control over it. These fluctuations directly affect the cost of producing electric vehicles. If the price of rare earth metals rises, the cost of the motor increases. And when the motor becomes more expensive, the final price of the car also goes up. In other words, the affordability of electric vehicles is closely tied to these hidden materials. But the issue goes beyond cost. An even bigger concern is geopolitical control. Rare earth mining is concentrated in only a few regions of the world. This means the supply chain isn't controlled purely by market forces. Politics and international relations also play a role. If supply decreases, exports are restricted, or production slows for any reason, the entire EV industry could feel the impact. That's why, despite its futuristic image, the EV sector carries a quiet vulnerability. From the outside, everything appears strong and stable. But behind the scenes, there is a dependency loop that is difficult to escape. Companies are constantly developing new battery technologies, yet the core of the motor still relies heavily on rare earth materials. This brings us to the issue of global dependency. Because rare earth mining is concentrated in only a few countries, EV manufacturers around the world depend on a very limited supply chain. This dependency is not only economic, it is also strategic. Any country that controls rare earth resources indirectly holds influence over the future of the EV industry. This creates a serious supply chain risk. If mining operations stop, logistics are disrupted, or exports are reduced, production across the industry could slow down. Automakers might be forced to wait for materials, delaying manufacturing and slowing the pace of mass production. Political leverage also becomes an important factor. Countries that possess large rare earth reserves can influence the global technology sector. And that influence is significant because electric vehicles are more than just cars. They are expected to become the main transportation system of the future. Another concern is the possibility of a production bottleneck. If the supply of these materials is limited, production capacity is limited as well. Even if companies want to manufacture EVs on a massive scale, they may not be able to do so because the necessary materials for their motors are restricted. This is why the future of electric vehicles may not be as secure as it appears from the outside. Technology is advancing rapidly, but its foundation still depends on resources that are not entirely stable, and this hidden weakness could eventually lead to a major transformation in the industry. When Elon Musk first talked about developing a motor that doesn't rely on rare earth materials, it initially sounded like a simple cost-cutting effort, as if Tesla was just trying to reduce manufacturing expenses. But when you look more closely, the idea seems far more significant than that. Removing rare earth materials from EV motors would represent a major technological shift. It's not an easy task. Developing such a motor is not only an engineering challenge, it's also an attempt to free the entire supply chain from a critical dependency. If motors can be built without rare earth metals, companies would no longer rely on resources that are scarce and vulnerable to sudden supply disruptions. This is where the strategy becomes clear. If Tesla successfully develops a rare earth-free motor, the company could become far less dependent on the global supply chains that the rest of the industry still relies on. That would allow for more stable production planning without the constant risk of materials suddenly becoming expensive or difficult to obtain. To understand the importance of this shift, it helps to look at the history of EV motor technology. Electric vehicle motors didn't evolve overnight. The technology has progressed step by step over many years, with each improvement pushing the industry forward. In the early days, most electric vehicles relied on permanent magnet motors. These motors were popular because they could produce strong power while remaining compact in size. They also offered excellent efficiency, which made them ideal for electric vehicles. This is why permanent magnet motors quickly became popular in electric vehicles. They offered strong performance, compact size, and excellent efficiency. However, as mentioned earlier, they also came with a significant weakness: their dependence on rare earth metals. While these motors delivered power and efficiency, they also introduced supply risks and cost uncertainty. Tesla decided to take a slightly different path. In its early vehicles, particularly the Model S and Model X, Tesla used induction motors instead of permanent magnet motors. Induction motors work differently because they do not rely on rare earth magnets. Instead of using permanent magnets to create a magnetic field, they generate the magnetic field electrically. In other words, there are no permanent magnets inside the motor. This approach had a clear advantage. It avoided the dependency on rare earth materials. However, induction motors also came with their own set of challenges. Generally, they are less efficient than permanent magnet motors and may require more energy to achieve high levels of performance. Even so, Tesla proved that induction motors could still deliver impressive power and performance. This helped change public perception and showed that electric vehicles could be fast and capable even without permanent magnets. But the evolution of EV motors didn't stop there. As the electric vehicle industry continued to grow, manufacturers began searching for a balance between efficiency and performance. In some cases, companies returned to permanent magnet motors because of their efficiency advantages. In other cases, induction motors continued to be used for their flexibility and independence from rare earth materials. Today, the industry appears to be approaching another turning point: the rise of hybrid motor concepts. The new idea is simple. Instead of relying on a single type of motor technology, why not combine different approaches? Could a system be created that offers both the efficiency of permanent magnet motors and the independence of induction motors? This is the direction many next-generation motor designs are now exploring. Tesla has a history of challenging conventional approaches. The company played a major role in bringing induction motors back into the spotlight in modern electric vehicles. Now, discussions about rare, earth-free motors seem like the next step in that journey, almost as if Tesla is rethinking the fundamental design of EV motors. And this is where the story becomes even more interesting. A rare, earth-free motor isn't simply about removing certain metals from the motor. The real change may lie in how the motor itself operates. Most electric motors today rely on permanent magnets that constantly maintain a magnetic field. This magnetic field allows the motor to rotate and produce motion. But if those magnets are removed, how does the motor create rotation? This question leads to a new engineering approach. Instead of using a permanent magnetic field, engineers could create a controlled magnetic field. In this system, the magnetic field inside the motor would be generated dynamically and adjusted as needed. In other words, the motor would no longer rely on a fixed magnetic system. Instead, it could become a more responsive system that adapts to changing conditions. And this is not just a hardware innovation. Software plays an equally important role in this concept. Advanced control software could manage the motor's behavior in real time, deciding how much torque is needed, how much power should be delivered, and how the motor should respond at different speeds. With this approach, the motor would not only be powered by electricity, but also guided by intelligent algorithms. Another important aspect is advanced torque management. In traditional motors that rely on permanent magnets, torque is relatively constant because the magnetic field is always present. However, if the magnetic field is generated dynamically, torque can be controlled more precisely. The motor could deliver more power when high performance is needed and reduce power during lighter loads. This flexibility could significantly improve overall efficiency. In essence, permanent magnets could be replaced by a system based on controlled electromagnetic fields. Instead of fixed magnets, the motor would rely on electrically generated fields that can be adjusted in real time. This could make the motor far more adaptable and flexible in its performance. Interestingly, this transformation would be almost invisible from the outside. The car would look the same, sound the same, and deliver similar performance. But internally, the technology powering it could be completely different. And perhaps this is the hidden innovation behind rare earth-free motors. Not just a small improvement, but a new direction for electric vehicle technology. If this technology proves successful, its impact will not be limited to Tesla alone. It could affect every automaker that currently relies on permanent magnet motors. Companies like Toyota, BYD, and many traditional car manufacturers have built their EV platforms around the assumption that rare earth magnets will always be a crucial part of electric motors. If that assumption changes, the entire industry may need to rethink its approach. Today, many automakers have built their entire EV ecosystem around permanent magnet motors. Their supply chains, manufacturing processes, and engineering designs are all structured around this technology. But if a motor system emerges that can deliver strong performance without relying on rare earth materials, it could challenge the very foundation of this design approach. Imagine Tesla's new motor concept proves successful. Other companies would immediately face a difficult question. Should they continue with their current motor technology or completely rethink their strategy? If a rare earth-free motor turns out to be cheaper, easier to scale, and more stable in terms of supply, traditional motor designs could slowly lose their appeal. That would mean many existing systems, once considered industry standards, might start to look outdated. Technologies that companies have relied on for years could suddenly face the risk of becoming obsolete, and the impact wouldn't be limited to technology alone. It would also affect manufacturing strategy. Changing motor technology isn't a small adjustment. It requires redesigning production lines, restructuring supply chains, and reworking testing and development processes. In many cases, companies might have to rethink their entire manufacturing model. For long-established automakers, this could be particularly difficult. Their systems are large, complex, and deeply integrated into existing operations. Making such a change is not easy. On the other hand, companies that operate with a more innovative and flexible mindset can shift direction more quickly. This is why rare earth-free motors could become more than just a new piece of technology. They could create pressure across the entire industry, forcing competitors to rethink their strategies. If that happens, competition in the EV world may no longer focus only on batteries and driving range. Motor technology itself could become a new battlefield, and this brings us to one of the most important questions. If rare earth magnets are removed from EV motors, what happens to performance? Will efficiency drop? Will the vehicle lose speed or driving range? This is the central mystery of the energy efficiency trade-off. Permanent magnet motors are highly efficient because the rare earth magnets inside them maintain a strong magnetic field continuously. The motor doesn't need to spend extra energy repeatedly creating that field. That's why these motors are known for delivering strong performance while consuming relatively little energy. But if those magnets are removed and replaced with a system based on controlled electromagnetic fields, the motor will have to generate its magnetic field electrically. That means additional energy may be required to create and maintain that field. This is where the real engineering challenge begins. And this is what makes Elon Musk's claim particularly interesting. He has suggested that Tesla's new motor design aims to eliminate rare earth materials without sacrificing performance. In other words, the goal is not only independence from rare earth supply chains, but also maintaining the same level of efficiency and power. However, achieving this balance is far from simple. If a motor constantly needs to generate its own magnetic field, efficiency could decrease. And in electric vehicles, efficiency has a direct impact on range. Even a small drop in efficiency can reduce how far a car can travel on a single charge. This is where advanced software optimization becomes crucial. Next-generation motors may rely not just on hardware, but also on intelligent software systems. These systems could manage the magnetic field dynamically, deciding when to generate it, when to reduce it, when to increase torque, and when to lower it. All of these adjustments could happen in real time. Instead of consuming energy continuously, the motor would only use the energy it actually needs at any given moment. Through this kind of smart control, software could help balance efficiency and performance. In a way, the real competition may no longer be magnets versus electricity. It could become hardware versus intelligence. And that leads us to another possible shift in the EV industry. Until now, the biggest area of competition among electric vehicles has been battery technology. Automakers have focused on questions like whose battery lasts longer, which one charges faster, and which company can produce batteries at the lowest cost. Batteries have been at the center of the EV race. But if motor technology also undergoes a major transformation, a completely new area of competition could emerge. In the future, the battle in the EV market might not just be battery versus battery, it could also become battery versus motor. One company might lead in battery innovation, while another could gain an advantage through more advanced motor technology. Some companies may excel in efficiency, while others may dominate in production scalability. This shift could reshape the competitive balance of the EV industry. Automakers that have focused primarily on battery development may need to invest just as much attention into motor technology. If motor design begins to influence cost, scalability, and supply chain stability, it could become just as important as the battery itself. In the future, the true strength of an electric vehicle may not be defined only by its battery, but also by the technology powering its motor system. This shift could potentially change the direction of competition in the EV industry. Now let's look further into the future and imagine that rare, earth-free motor technology truly becomes successful. If that happens, the impact will go far beyond just engineering improvements. It could reshape the entire electric vehicle ecosystem. First, let's talk about cost. One of the biggest reasons EVs still feel expensive today is the cost of their components. Batteries are a major factor, but the motor and the complex supply chain behind it also contribute to the overall price. Rare earth metals, which are commonly used in EV motors, do not have stable pricing. Their prices can rise quickly, and supply can sometimes become limited. When this happens, the cost of building electric vehicles increases as well. If motors no longer depend on rare earth materials, one major cost pressure could be reduced. This doesn't mean electric cars would suddenly become extremely cheap overnight, but it could open the door for gradual and consistent price reductions. And that leads to an exciting possibility. The dream of a truly affordable EV today, many electric cars remain out of reach for average buyers. But if motor technology becomes simpler, cheaper, and easier to scale, building a low-cost EV could become far more realistic. In the future, we could see electric cars priced similarly to traditional petrol vehicles. This change wouldn't only benefit individual buyers, it could also transform commercial transportation. Taxi companies, logistics providers, and delivery services are eager to adopt electric vehicles because of their lower running costs. However, the high initial purchase price often slows down adoption. If EVs become cheaper to produce and easier to manufacture at scale, fleet electrification could accelerate rapidly. Imagine thousands of delivery vans, taxis, and trucks switching to electric power. Operating costs would drop significantly, and adoption could increase at a much faster pace. Another important impact would be in developing countries. At the moment, EV adoption is largely concentrated in wealthier nations where infrastructure and purchasing power are stronger. In many parts of the world, people are still searching for vehicles that are affordable, durable, and reliable. If rare earth dependency is reduced and motor production becomes simpler, manufacturing could expand to more regions. Local production of EVs could become easier in developing markets. This could make electric vehicles more accessible in countries across Asia, Africa, and Latin America. In other words, EVs might gradually shift from being a technology mainly used in rich nations to a transportation option available worldwide. This transformation wouldn't happen overnight, but it could be profound. Lower costs, higher production capacity, and reduced supply risks could together reshape the speed of EV adoption. If these factors align, rare earth-free motors could become more than just a technical improvement. They could help bring electric vehicles to the global mass market. And the impact wouldn't stop with individual companies. If this technology works successfully at scale, it could influence the entire global EV market. Right now, the EV industry operates within a delicate balance. Some countries lead in technology development, others control key supply chains, and some dominate manufacturing. Rare earth metals play a major role in maintaining this balance. Nations that control these resources hold indirect influence over electric vehicle production worldwide. But if EV motors no longer require rare earth materials, that balance could begin to change. The biggest impact would be on the supply chain. Currently, many manufacturers rely on a limited number of sources for rare earth materials. If those materials are no longer necessary, EV production could expand to many more regions. This would mean manufacturing is no longer concentrated in just a few countries. Such a shift could transform the global manufacturing landscape. New companies, new regions, and emerging markets could enter the EV industry without needing to manage the complex logistics of rare earth sourcing. Price competition could also intensify. If some manufacturers manage to produce affordable vehicles using rare earth-free motors, others will be forced to lower their prices to remain competitive. This could create strong price pressure in the global EV market, especially in regions where consumers are highly price-sensitive, such as Asia, Africa, and Latin America. Up to now, EV growth has mainly been concentrated in developed countries. But if production costs drop significantly, entirely new markets could open up. Technology competition would also expand. For years, most EV innovation has focused on battery technology, improving range, charging speed, and cost. But if motor design becomes a major differentiator as well, a new wave of innovation could begin. Companies might start competing not only on battery performance, but also on motor efficiency, intelligent control systems, and manufacturing scalability. Investment trends could shift as well. Previously, much of the investment in this sector focused on rare earth mining and the related supply chain. In the future, more investment could flow toward advanced motor designs, software-driven control systems, and innovative manufacturing techniques. And perhaps the biggest impact would be on the speed of EV adoption worldwide. If costs decrease, supply chains become more stable, and manufacturing expands, the global transition to electric vehicles could accelerate dramatically. In that case, rare earth-free motors wouldn't simply represent a technological improvement. They could become a key factor in reshaping the global EV market. In the future, competition in the EV industry may not depend only on technology, but also on access, scalability, and production capability. And this shift could determine the direction of the entire market. If you enjoy in-depth and easy-to-understand technology videos like this, make sure to subscribe to the channel so you can stay updated on the next big changes shaping the future.